Okay, so chapter 2, this is not on our exam. This will be on the second exam. You know, obviously it's chapter 2, so this will be on the chapter 2 exam. So y equals 7 sine of x. So first off, they're asking for the amplitude. So you determine there, what's the amplitude? Anybody know when you look at a trig function what where the amplitude is? Yeah, it's that number in the front. So it's just the 7. So that's all there is to this question. The amplitude is 7. They just want you to know it's a number in the front. What do we mean by amplitude? Well, yeah, rather than me just telling you that answer, let me show you what I mean. Well, a sine graph, how sine basically looks. It starts out here. It goes high and low, high and low, high. It just keeps going both directions, you know, forever. Dot, 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 dot. So that, you know, the x-axis, it just keeps going. Here's the y-axis, the x-axis. So the sine graph goes high and low, high and low, high and low, like that. How high does it go? It normally only goes up to a height of 1 and down to a height of -1. So know that about the normal sine graph. But if there's a number in the front, the amplitude, that amps it up. So that makes it come all the way up to 7 and down to -7. Basically, it stretches the graph vertically. That's what an amplitude, that's what a number in the front of a trig function, sine, cosine, well, we're just doing sine and cosine in this section. It just yanks it taller and it just vertically pulls it up and down. So that's what that says. Because the normal sine has a 1 in front, right? So it only goes up to 1 and down to 1. This has the 7 in the front. All right, now, right here, guess what this angle is? 360 degrees or 2 pi radians. Why? How do I know? Because it's done its whole cycle. And then it just repeats. See how after that it's just all, see how this section right here is just repeated right here? And then on and on. Repeated right here. Starting to repeat off to the right. It just keeps repeating that up and down, doesn't it? Just keeps repeating this. This is the sine curve. This is one period of the sine curve, isn't it? It does its whole thing right here between 0 and 360. Right? What does it do? It goes high, goes back down to 0, goes low, back to 0, right? It goes high and low, then high and low, and on it goes. It just keeps repeating that. All kinds of things in the real world do. That's why we made this up. So does that make sense? Now I haven't showed you, how do I know it does that? Well, you'd have to plug in a bunch of values. I don't want to waste our time. But if you made an XY table for y equals sine x, and you plugged in a bunch of values, let me just leave it at that. So you could plug in, 30 degrees, 60 degrees, 90 degrees, and da-da-da-da-da, and you'd find these dots rising and falling like that. That's what you would find for the sine curve. So good to put that one on for your next exam, the 3x5 card for the next exam. Good so far? So they just want the amplitude right now. Okay. So let's graph y equals -6 sine x. Okay. The -6 is the amplitude. You know what the 6 is going to do is, make it go up 6, down 6. But what about the fact that it's -6? What do you think that's going to do? It'll turn it vertically, is what it'll do. So, how do I write it? So negative amplitude is a vertical flip. Let me use this. So back here again. So negative amplitude. Amplitude is 6. Again, you don't say the negative, which I think is kind of dumb, but whatever. So you don't say the negative. They just want you to say 6. So, but because the amplitude is negative in the front, negative amplitude, it's a vertical flip, which means, what did they say? Rotate about the x-axis. Is that the language they used? Reflect, thanks. Reflect about the x. Is that confusing? Because I can see where that would be confusing. You think, wait a minute, it's a y, it went up and down. Yeah, but that is a reflection because this is the x-axis. If you go from there down to there, you jumped across the x-axis. The x-axis was like a mirror. You reflected across the x-axis. Everybody see that? That's why you click that box. reflect about the x-axis. So it makes it jump down. So basically that negative means that the normal sign, here's the normal sign, goes up 1, down, back to 0, right? That's the normal sign. So the -6 thing is going to make it go, instead of going up first, it's going to go down first. Down to -6, and then up to +6. Whereas the normal sign goes up to 1, down to negative, up to 1, down to -1. Everybody see that difference? See what's happening? So the -6 in the front makes it go down first instead of up first to -6. It's upside down. And you got to click the reflect about the x-axis box. On the exam, it'll be multiple choice. You won't have to click any boxes. You'll just be matching it up. Good on all that? Okay, y equals 5 sine a half x. Okay, when you start putting numbers in here, multiplied, it's going to change the period of the function. So the period is 2 pi over, let's call it w. You can call it whatever you want, where w is number or whatever next to x. They usually call it, it's technically omega, but whatever. Call it whatever you want. That's the way you'll see it in most math books. They'll call it, it's actually a Greek w, called omega, but whatever. It just means take 2 pi over the thing next to x. And that'll be the period of the sine function, meaning one cycle, right? So, everybody with me on this? How are we doing? I'm always wondering about an hour and a half in if you're still with me. Are we good? Yeah. Am I still coming across? You guys are giving me a little bit of a daze. Look pretty good. All right. Keep going here. 2 pi over, this is because it's important. This is probably the hardest, most important thing we've done all day, so I don't want you to be lost at this point. Catch this. This really matters. This will be a big deal on the second exam. So, grab that half. Put it down there. That's what I'm saying. So the way you find the period, and I'll show you what we'll do with the period in a minute, but first off, the period, one cycle, the width of one cycle, is 2 pi. I'm going to give you this little magic formula. You want to put that for exam 2. You won't need it for the first exam, but exam 2. Put that in your card for sure. Probably one of the most important things. 2 pi over omega, 2 pi over whatever's next to x, and then you know what to do. Flip that up. So 2 pi times 2 over 1, which is just 2. So 4 pi. Right? You with me? So that's 4 pi. So the period is 4 pi. What does that mean? Well, let's draw a picture. That means normally, normal sine, and they're always going to want you to put the normal sign on there. Normal sine goes up to 1, down to 0, right? Down to -1, back to 0. And it does that every what? 2 pi. Normal sine. That's the normal sine. They're always going to have you put the normal sign and then the new one. So that's normal sine x graph right there. Now, what is this one going to do that's so different? Well, his period is 4 pi. Meaning he doesn't finish his period, he doesn't finish his cycle by 2 pi. It takes him all the way to 4 pi. So he's going to go twice as far to here, to 4 pi, to do one cycle. What is one cycle for the sine function? Up, and up 0, down 0. That's one cycle. So that means this from here to here is 1. That's what this just told us. 4 pi is his period now for this sine function with the half x in there. 4 pi is his cycle. So what's half? What's halfway through his cycle? Because he always hits 0 halfway through, right? Even the normal sine function. You with me? He hits 0 halfway through his cycle. Am I going too quick? You catching these words? These really matter. So we're going from normal sine function to this one. So normal sine function hits 0 halfway through his cycle, doesn't it? So then the expanded cycle is also going to hit 0 halfway. Where's halfway through his cycle? Right here. So he's going to go up to 5 and down. It's going up to 5. Down to -5. Oh, running out of room down there. Oh, come on. Like that. This is -5. So up to 5, down to, I kind of don't have room down there, but whatever. There's what he's going to look like. So everybody see that. And then he'll just keep repeating that. Every 4 pi, boom, boom, he'll just keep doing that. But it takes him longer to complete a cycle. because that half in there slowed his cycle down a little bit. Does that make sense? Everybody see what I did there? So I found the period by this magic little formula. I haven't given you any good reasons for it, maybe later. 2 pi over omega, which is the number next to x, 2 pi over half, flip the half up, it's 2, 2 over 1, 2, 2 times 2 pi is 4 pi. So 4 pi, so when you find that, you go, okay, 4 pi is where he ends his cycle, half of that is 2 pi, so he'll go up and hit 0 at 2 pi, down and hit 0 at 4 pi. Let's put him on the graph. Is that good? So period, 4 pi. Changes the period. No questions? Super important. All right, try that one. Let me let you work on that one. You got some knowledge now. Try that one. Start with the amplitude and the period. See if you can do a little quick graph. The W is the pi this time. It's whatever's next to x, right? Am I losing you? Well, let me let you work for a second. All right, how we doing? We good? We'll jump in there. So, what's the amplitude first off? Careful.
4.
Yeah, not -4, huh? It'd probably fool me. All right, and what's the period? It's 2 pi over omega, they call it officially. 2 pi over whatever's next to x. 2 pi over pi, yeah, just 2, huh? Not 2 pi, whatever pi. It's just 2. Good? Everybody good with that? So that's kind of weird, huh? Having the period just be like a normal number without a pi. The period's just plain 2.
That's the work. What?
What's that?
That's the work.
Yeah, that will work. Yeah, let me show you. So everybody good to there? That making sense so far? Use that formula, 2 pi over whatever's next to x, which was pi itself, cancels 2. So now what is it? What does period mean? When it finishes its first cycle. Right? So start at 0, finish your first cycle where? 2. Not 2 pi, but 2. You with me? Okay. And halfway there is obviously 1, and that's when it hits 0. So it's going to go up and hit 0. Oh, actually, and this one goes down first, doesn't it? So this one's going to go down to -4, hit 0, up to +4, hit 0. There we go. That's its first cycle and just keeps repeating. Is that making sense on that? Does one cycle by 2, halfway at 1, down first. So I won't bother going to the graph thing. Yeah.
Do we do reflect over the x-axis because it's negative? The amplitude?
Oh, yeah, yes. You do need to do reflect over the x-axis. Yeah, you're exactly right. Yeah, good job. That's reflect across the x-axis. Exactly right. Because, yeah, it's flipped upside down. Yep, got to choose that. We got to put the period 2. That's right. And amplitude 4. That should work. Good on that? We good? All right. So we've got y equals sine of x plus pi over 2. Okay, so this is a number, or something. Let's just say, yeah, it is a number. Number added or subtracted next to x is a phase shift. Well, yeah. Let me say that better. The phase shift phase shift equals opposite of any number added, subtracted next to x. Do you see the difference between this and what we did in the last couple of problems with the period thing? That number's not times to the x. It's added or subtracted with the x. That's the difference. If you have a number multiplied by the x, that changes the period, the width of one cycle. If you have a number added or subtracted, that's just going to shift the graph. It's going to move it. The opposite. So the phase shift is going to be negative pi over 2. It's opposite. Everybody see the opposite there? So if they gave me x minus pi over 2, then the phase shift would be positive pi over 2. It's the opposite sign. I'll give reasons later. Let's just get comfortable with it for now. So does that make sense? Everybody see the difference between this? I'll come back, but see the difference here? Like this pi is not on this last. I'm just gonna knock everything out. Pull the thing out. All right, come on back so I can point to you. It's really mad that I unplugged it. There. Okay, so this pi, that is times the x, right? So that's not a phase shift. That's not what, when I say what a phase shift is going to do is going to move the graph. This is a stretching horizontal. Period shift. See the difference? So you really want to know the difference. There's a fundamental difference. If you have numbers multiplied by the x, that's what's going to stretch the cycle, which we saw. It stretched it to 2. Right? That stretches the cycle. Whereas this one, when you have numbers added and subtracted next to the x, that doesn't stretch it or compress it. That just slides it, shifts it. A phase shift, we call it. But it's just as wide. One cycle is the same. You know, the period will not change at all. The period is still just the normal period for sine is 2 pi. No change at all. Period's just 2 pi. No change in that. Numbers added, subtracted, just shift the thing. And they shift it the opposite of whatever's there. So it's a negative pi over 2 shift. Let's see it on the graph. We good with that? Okay. Determine the amplitude, period, and phase shift of the function. So try that. Can you read that one? So y equals 3 sine 4x minus 2 pi. So try that one. So first off, find it's going to ask you for the amplitude, period, phase shift, which is going to have a new wrinkle. I'll show you in a minute. Do the basics first off. Do the basics on that one. So what you can do on the basics there, and then I'll jump in on that last part. All right, so I got to do something special here. So what's the amplitude? Amplitude's 3. Okay, what's the period? It's 2 pi over what? What's it over?
4.
Just the 4. Very good. Y'all good on that? It's just the number multiplied. It doesn't have anything to do with that other negative 2 pi. We'll get to that. It's going to do something weird in a second. So that's just pi over 2. We good so far? Everybody okay? That's the width. And what is that? That's the width of one cycle. It's the width of one cycle. Right? Each cycle. Okay. So now phase shift. It's going to do something special. Going to be something weird. Let me just write it for you this way. Sine of a. Let's just call it ax plus b. Let me get rid of the w thing. This might just be easier for you. Let's just. Well, actually, you know what? I'm trying to be like your book, so it might help. Let's do this. Let's call this a in the front. A for amplitude. That'll work. Call this b and call that c. I'm actually doing something a little different than your book because I think this will be easier for you. So I'm just making up names so I can give you a formula. Just call whatever's in the front A, call whatever's multiplying x b, and whatever's added or subtracted afterwards, call that C. The phase shift, now, remember how it's opposite? It's negative C over B. It's negative C over B. And period, if I wanted to write a nice period formula for you, let me go back. It's right. Our answer was right for period, but let me just write it in the new formula format. It'd be just 2 pi over B. I called it W before. I noticed, I was just looking at your book. I noticed your book calls it B. So let's just call it B, so it's consistent with your book. Different books call it different things. 2 pi over 4, as we already said, the period's pi over 2. So anyway, back to the phase shift. So this is what's new for the phase shift. A minute ago, I said it's just the opposite of whatever's out here. That's true as long as there's no number multiplying x. See on the last problem how there was just a 1 here? So it was just the opposite of that, right? Which is true, because it's just minus pi over 2. If you want over 1, which does nothing, it's just minus pi over 2. That was true. Now, there's a number here. So we got to be a little more careful. It's the opposite. This means opposite, right? The negative. Negative on anything means opposite of it, doesn't it? It doesn't mean it's going to necessarily come out negative. Because if you put a negative on a negative, it's positive. Right? It means opposite of. That's how you want to start thinking about negative signs now as you're moving on into higher math. Negatives don't mean everything's negative in them. They mean the opposite of whatever, don't they? That's really what a negative on a letter does, is opposite. So think of it that way. That'll be much better for you as you move on to pre-calc, calc. So opposite of C over B. So opposite of C, what's C? That's C. Opposite, yeah, so here we have a case right now. Opposite of negative 2 pi, it's going to end up being positive 2 pi, over B over 4. So it's 2 pi over 4, which is pi over 2. That's weird. Phase shift comes out the same as the period. Coincidentally. Are you with me? Did that make sense? And the phase shift, what is the phase shift? Where the graph starts. That's where the graph starts. And the period, as you know, is the width of one cycle. So the period is the width, how wide a cycle is, and the phase shift is where it starts. Notice it doesn't start at 0. This graph will not start at 0. It'll start at pi over 2. So are we good with all that? Everybody see how I did that? So again, the phase shift, you're going to want to put these for the exam too on your formula sheet. Negative C over B. So it's negative, and C is negative 2 pi. It's whatever comes after the x. Negative 2 pi over 4. 2 pi over 4, pi over 2. So let me draw the graph on that one. I'm kind of out of room. Yeah, let me just come up here. I'll just put it up here. So we've got the information, and you could do it on the grapher thing, but let me just do it right here by hand. What does this mean about the actual graph we're talking about? That means this graph will start at pi over 2. So right here, start at pi over 2. It won't start at 0. It'll start at pi over 2. And it'll do a full cycle every pi over 2 after that. Okay, so what's another pi over 2 after pi over 2? If I add pi over 2. Start at pi over 2, add another pi over 2. What's pi over 2 plus pi over 2?
2 pi over 4.
2 pi over 4, better known as, oh no, not 2 pi over 4. Right? Pi over 2 plus pi over 2. It's 1 pi over 2 plus 1 pi over 2 is 2 pi over 2. It's just pi. It's half a pi and half a pi. It's a pi. It's a full pi. You with me? Right? This is 1/2 a pi and 1/2 a pi. It's a full pi. What am I saying? It's going to start here, do a full cycle, meaning go up to 3, down to 0, back to there. Went up to 3, because the amplitude's 3, down to negative 3, hit 0 halfway through, and did a full cycle. Does a full cycle between pi over 2 and pi. Kind of squish that thing in there. And then it'll just keep repeating that to the right and the left forever. That's what the grapher would show you if I could do it. If I get a pi over 2 thing on my screen, it's what it would show you. I'll try to fiddle with that in my office so I can know how to help you with that later. But for now, that's what it'll look like. Is everybody making sense out of that? How are we doing? Is that good? right? So again, the phase shift is where it starts, and the period is the width. So if you start at pi over 2 and you go pi over 2, you end up at pi. And it's going to do a full cycle in that width, which means high, 0, low, 0. All right. Okay, so try that. And they're going to ask you the big three questions. What's the amplitude? What's the period? What's the phase shift? Which means where does it start? See if you can do those. Use those formulas I just gave you. All right, what's the amplitude?
4.
Yeah, 4. You just give the positive versions, you know. Period. So it's 2 pi over whatever's multiplied next to x over 2. Yeah. Period's pi. That's the width of each cycle. Okay, and the phase shift is negative c over b. Isn't it? I should have written the period formula. Here, let me redo the period thing. The period, it was right, but the period is 2 pi over b. It's 2 pi over 2. It's pi. And the phase shift is negative c over b, so it's negative 2 pi. This is b, and this is c. ABC. ABC, right? So negative 2 pi over b, which is 2. So that's negative pi. We good on that? And that's where it starts. It starts at negative pi. So can we draw the graph? Can we get a little picture of the graph? Let's try. We're going to start at negative pi, so I'll come back here at negative pi. That's where it's going to start. And what's the width of it? It does a full cycle every pi. So starting from negative pi, right, you're going to add pi, add 1 pi, because it does a full cycle. Oops, didn't mean to erase that. Every pi. Am I going too quick? Am I losing you with that point? So this is real important. It's about as messy as these get for now. Does that make sense right there? So you start at negative pi, and then you jump, you cover 1 full cycle as you go from the start at negative pi plus 1 pi more. Right? That's 1 pi. That's 1 period. So if you're at negative pi, you get to 0, won't you? Negative pi plus 1 pi brings you to 0. So it's going to do 1 full cycle between negative pi and 0. Is that making sense? How I came up with that? I start at negative pi and I add 1 full cycle width, 1 period. I get to 0. So what's halfway between, well, you don't even need to show it. What is it going to do between those bounds? It's going to do 1 full cycle, which means it's going to rise and fall. It's rise 0, fall 0. Right? High 0, low 0. So, and how high? 4. Oh, negative. I didn't know negative. It's going down first. That just means it's going down first instead of up first. So it's going to go. So halfway through it'll be at 0. It's always 0 halfway through, isn't it? So I'll put that in there, probably help. It's going to go down to negative 4, back up to positive 4, back down. This is, this is positive 4. This is negative 4 down there. And then it'll just keep repeating now to the right and the left forever. Does that make sense? Can you already start to see real life, what they do with this? They take something in the real world, the tides coming in and out, or the daylight. How do they, the cycles of us with the sun and the daylight, we're getting into shorter days now, right? It's getting darker earlier. How do they predict all those? Those are sines and trig functions. And they look at what's happening, they look at the period, they look at that amplitude, and they make a trig function to fit it. That's exactly what they do, like we're doing right now. Yeah, question? Oh, roll. Maybe I should do roll. Yes, I probably should. All right. All right, I'm going to stop there.